All right, welcome back, everybody, to our second session of Hack Central. This is a once-a-month activity which we usually do to deep dive into some deeper topics of computer science, which Andrew and I aren't able to cover usually in our Tech Bytes, where we explain the fundamentals and learning how to program in languages such as Python and JavaScript. So we looks like we have some people from Tech Bytes, so you guys already know who I am. My name is Rayaan Siddiqi. I'm a rising senior at James B. Cohen High School. I've made multiple apps for the App Store, like to make websites and like to make some content on the side. If you want to learn more about me, you got my website at rayaansiddiqui.com. And for one last time, my partner Andrew.
Hello, my name is Andrew Choi. You may know me from the previous Hack Central. As Rayaan suggested very earlier, this will be my last Hack Central. In terms of what I do, I am also a bit of a coder as well. I'm particularly interested in computer graphics. I illustrate on the side, and I will be a freshman at Purdue University quite soon. You can actually check some stuff I've done at andrewchoi.info.
And speaking of some of those other programs, guys, looks like if you aren't already enrolled in our Tech Bytes program, so be sure to enroll in that as well. We have changed the dates up, so if you remember from the old sessions, if you're on a Google Classroom, you already know about this. But in case you don't, Tech Bytes is essentially where Andrew and I, well, at least for this last week with Andrew, we teach the fundamentals and programming languages such as Python and JavaScript. We make cool projects, and we really learn about how to start coding, and we make nice transitions. So that is on Monday and Wednesday, and can be found under Intro to Programming as the first course, and the second course can be found under Web Development. So if you're interested in Hack Central, Tech Bytes is definitely related, and you'll enjoy that as well. And our other program is Teen Trivia every Friday, and every other Friday. And this Friday, we will be having a game of online trivia on CrowdPer, where you can top 5 people win gift card prizes. So that's a little fun event we do every other Friday. So if you're interested in that, be sure to sign up. It can be found under Teen Trivia on the library's website.
Right. Today we will be talking about machine learning, particularly the k-nearest neighbor algorithm. It's an algorithm, right?
Yep.
Yeah.
All right, so if you remember from our last Hack Central, we talked about using the programming language of Python. Well, today we're going to be using Python once again. And in case you might be asking, why are we using Python so frequently when doing machine learning tasks? Well, one of the main reasons is that Python is a great language for implementing machine learning algorithms, like the one we learned about last time, that being linear regression, support vector machines, and now today, KNNs. There are a bunch of libraries and frameworks such as TensorFlow, NumPy, Keras, and Matplotlib, which allow us to manipulate our data, visualize our data really nicely. And all in all, Python is one of those main driver languages for machine learning. All right, so let's talk about what is the k-nearest algorithm, or KNN for short, and how it compares to what we learned about last time.
All right, so what is k-nearest neighbor? It is, for the most part, a way to make classifications given data sets. Now, there's also a way to assign numbers, but we'll talk about that in a bit. Just think of it as a way of putting things into groups. We can see that the way that a data point is actually selected for a group, what group is selected for its given data set, it's actually dependent on the most frequent class among the k-nearest neighbors. This means that if you had, we actually have the example on the right of the slide. If we have a data point and we plot it right there, we look at the k, we'll say k equals 5 for now, the 5 nearest neighbors on the graph, and we see what categories or classes those 5 other data sets belong to. And we find what is the most frequent neighbor class. So right here, we can actually go to a different slide. We'll see in a bit with colors. But going on to Rayaan, let's talk about what regression is.
Yeah, so if you remember from last time, if you were attending Hack Central, our first rendering last month, you remember that we talked about linear regression. And one of the key points which we emphasized was that, in general, regression was a way for us to make a prediction. If you remember from a month ago, we made a prediction of a student's third trimester grades using attributes and labels such as how well a student was performing, their attendance, and the number of failures they had. Well, using that data, we were able to make a regression, using regression, we were able to make a prediction. And regression is generally done with numeric data. Well, today we're exploring a second side with the KNN algorithm, that being classification. We're going to be identifying where that data point belongs, not going to be making predictions necessarily. And if you look, classification is generally usually done with words types of data. So I believe this example, if you look at the bottom, explains it much nicer. So say we have a house. We want to predict the price of the house. Well, the price of a house is usually a numerical value, correct? Well, how's the price of a house determined? Well, if you think about regression, we can use input data such as the size of the house, the location, the schools which the house belongs to, and all of that shapes into the price which can be predicted. This is the concept of regression. And then if we have, on the other hand, we have classification, which think about in words of the house. So say the house is very costly, is costly, affordable, cheap, or very cheap. Now these words will be similar to an example which we applied today, but this idea relates to classification of classifying that house into one of these price categories. So the main idea which we want you guys to take away today is that regression is making predictions, while classification, well, it's identifying where the data point belongs. And we got a nice little example here which will really put things into perspective.
All right, so say we had a graph with a bunch of data and some categories that are associated with the data sets, with the points already in the data sets. So let's say we want to actually classify the black dot. So the way we actually would find that is that we would find the number of data points most nearest to that black dot. So in this case, we usually say K as a sort of like placeholder. You know, it's K equals 5, K equals 7. Those of you who had an algebra class, you'll know what we're talking about. So let's just say that there's K nearest neighbors, and we say that, hold on, I'm just like, it's me number. Yep. Should we move on to the next slide, or?
Yeah, so let's actually apply a number and set the variable K to a numeric value. And in this case, say we say K equals 3. Well, since we said we're looking at the 3 nearest data points, we're going to look at the 3 closest data points to this black dot. Well, in this case, all 3 of the nearest data points are actually the color blue, which is why this black dot will be classified as a blue class. Now, notice how we picked an odd number for K. Now, you might be wondering, can we pick any number? Well, yes and no. The number can be any odd number. You might ask, why can't we choose an even number? Well, think about it this way. Say we chose K equals 4, and our data point was, say, more in the center right here where my mouse cursor is. Well, say 2 points are closest to the yellow class, while the other 2 points of the K values we assigned are closer to the blue class. Well, that's a split, 2 yellow, 2 blue, which is why you must choose an odd number for K in order to make sure that a definitive class is assigned to whatever data point you're looking at. And in this case, hopefully this visualization makes sense that 3 closest we're looking at, those 3 closest points are in this case that blue class, which is why this black dot is now considered in the blue class.
All right, so now we're going to actually look at some of the math behind this algorithm.
Yeah, so I guess we'll see it's a whiteboard.
And by the way, we know that this is quite a lot of information that we're sort of giving you right now. If anybody has any questions, any comments they'd like to make right now, feel free to put that in Q&A or the chat, and we will get right to you.
All right. All right, so you guys, can you see that, Andrew?
Yep, I do.
All right. So let's take a look at some of this math with this whiteboard. All right, so this is pretty much, I believe it should be Algebra 1 math. Nothing too difficult, which we'll be going into today, but definitely a step up from our linear regression math, in which we talked about slope and y-intercept and all that, and how to make a prediction and the line of best fit. But today it's a bit different, because remember, say for now, let's say we have a, let's start off with a 2D type of graph. We have an x and a y axis. You got the x and we got the y axis, right? Now, say we have one data point right here, and we'll say this is the blue class, right? This represents all the blue circles, so just pretend those are circles. And then say we have this yellow, this other data point, which we want to classify. And just for sake of understanding, we'll put one more color. Say we got this red. This is the other class, the red class. Now, how do we figure out which class will this yellow data point be classified as? Well, there's one formula which we use called the distance formula, if you remember. So we have this point on our plane, on our graphs, and this has some type of coordinates. So say it's usually x, y. Oh, can't really draw this that well. X, y, right? And then all of these points in this blue class and this red class also have an x, y coordinate. Now say we'll call this x2 and y2, and we'll call this blue class data one with this data point. We'll say that's x1 and y1. So how do we determine the distance between those data points? Well, it's a pretty simple formula. We just do this the difference of the x coordinates squared plus the difference in the y coordinates. And you can guess that is squared as well. Now, say whatever we say, for easy purposes, we'll say that distance is a whole number of perfectly 4, right? Between the yellow point, which we want to classify as blue or red, and the original blue class. So the distance between the yellow and the blue is 4. And then using this same formula, the distance formula, we can figure out the distance between this yellow point and the red class. And say this is for the distance between the blue one, the blue class, and say the distance between the yellow and the red is 5, right? This is the distance between the red and the yellow. Well, obviously we want to choose the lesser distance, because that's which color our yellow point will be classified as. Well, in this case, 4 is less than 5, which is looking like our yellow point will be classified as a blue dot. Andrew, if you want, I can give you remote control access too if you want to add on anything, or...
Sure, I just want to make a few comments.
Yep.
Bear in mind that unless you have some type of shortcut that's sort of embedded in how you check, you usually need to check all the points for distance. So usually this is why we use computers to actually do all of these numerical filtering. So a computer will have, all right, so we have this dot here, we'll call it A. And all the other dots, we have B1. This could be just like this dot over here, B2, B3, and really just into infinity, really. Of course, computers can actually do infinite stuff, but it does give you an idea for how computers are able to take a large data set and then by essentially performing a distance calculation on each of them, find that that minimum distance between the data set, and then find those k nearest neighbors that we usually want to classify the data with.
All right. All right, so now that we have a basic understanding of the math behind the KNN algorithm, how about we actually put it into use and apply it like we did last time? So here's our scenario. So our scenario will be basically as follows. We want to classify the condition of a car we want to purchase given these 4 inputs or labels. Well, what are those inputs? One will be looking at the buying price, the maintenance of the car, the number of doors a car has, and the safety ratings. Using all this, we would classify our car as being within one of these 5 attributes, essentially. That being unacceptable, acceptable, very good, good, or just all right. All right, so let's run a real example and see what happens. Classifying a car's condition. Let me 1 second. Let me just pull this up. All right, can you guys see that the code in PyCharm? Can you see that? Andrew, can you guys see?
Yeah, I can see your code.
All right, great. All right. So we don't want to get too much deep diving into the code, but we'll do a brief overview like we did last time. We have some import statements. You don't need to worry much about that. We're just using these libraries to make our lives easier when importing and reading our data. One of the main ones, which I would really like to highlight, is pandas. Now, not the animal pandas, but in this case, pandas is a library which allows us to read in all of this data. And we can usually import it and separate it if it's a CSV, like comma separated value sheet, or whatever the case might be. And once we have the data loaded up, we are using a label encoder, which allows us to convert a string value into a numerical value. That might sound a bit confusing if you're from our Tech Bytes session, so don't worry too much about that. But just showing the main idea that we're using these attributes to classify our car as being very good, acceptable, and we'll see that printed out in the console in a little bit. Remember from last time, Andrew made a good analogy. I think you said, Andrew, that you would never use this about the test. You said you don't know the test answers before the actual test, I believe is what you said. And similarly here, we're dividing our data up so that the test data is different from the training data.
Yep.
And here is where we actually are separating the code into our KNN algorithm. So if you remember last time, we did a similar code. If you remember, we divided our data up, but here is where it specifically goes into the KNN algorithm, where we're assigning the number of neighbors. In this case, we're saying, look at the 7 nearest data points and use that to classify our car's condition. And here we are training our model, and let's see it run. All right, here we go. So here, essentially, I just printed out the accuracy of our model. We can see it's 95%, which is super good. And we can see what our prediction or what we're classifying our car as and what the actual car was. So if we go through a couple of these, we can see that the model is doing pretty good. It classified our car as being good, and the actual condition of the car was good. Predicted was good. Actual condition was good. I'm trying to find one where it did not match up. Here we go. So it predicted good. The condition of the car was good, classified as a good condition. However, actually, it was an unacceptable car. So why? Well, there's always going to be discrepancies, and you can obviously tweak the numbers more, play around with the number of neighbors you're analyzing to up this number of your accuracy of your model. And yeah, so here is a live example of us checking using the data which we loaded in, such as the number of doors, the safety, the number of people it can fit, maintenance, and using all those labels to classify our car's condition.
And bear in mind, there's a reason why they call it machine learning. Of course, there's always going to be a little bit of imprecision in how intelligent the actual prediction is.
Yep.
All right. So one thing that is a big problem, and I sort of mentioned this earlier, when you have data sets and you are running this sort of distance algorithm, you're doing it to all the data, not just like a few pieces of data where it's like you have the linear regression and you have like that line and you might have like a few, you can get a decent approximation about what the line looks like using a few data points. You don't quite have that in the actual KNN algorithm. You have to check each point to know if the point is closest. So there is sort of that redundancy. Now there is I believe that there are some ways to sort of like take shortcuts. I believe that it's called spatial partitioning. Do they have that in KNN?
I think that's in SVMs, the support vector machines. I'm not sure about KNN.
Either way, so that is definitely a drawback. Brand, do you have any other ones?
Yeah, so the main idea is just that the training time, which as a result impacts the data usage. This algorithm is very computational heavy because if you think about it, say you have hundreds of thousands or even millions, which big corporations nowadays do using this KNN algorithm, you have millions of different classes which you want to analyze. Well, this algorithm would take a pretty long time to run because you're applying the distance formula, x2 minus x1 squared and the square root of all that plus y2 minus y1 squared. You're applying that for each and every data point. So looking at the data point you're entering to every single point, which can be very redundant. And as a result, it can up the cost in a business model. And it's a nice algorithm. It's a nice one to visualize, definitely. But in actual application, it's not that widely used just because of the training time and how computationally heavy it is.
And bear in mind, we don't just know like that it is computationally expensive. We know how computationally expensive. Yes. In fact, computer scientists have actually invented a form of notation for describing how expensive it is. It's called big O notation. It's n squared. You don't need to actually know that much about how the actual big O notation works, but think of it like this. If you have three, I'm going to type this into the chat. Actually, do you have the whiteboard?
Yeah, yep. Let me open it up.
Yes. So can you actually clear this out real quick?
All right, go ahead.
All right. So if you have 3 data points, keep in mind that the computer scientists say that this algorithm it's n squared complexity, right?
Yeah. Oh, n squared.
Yeah. So that means that this is just an approximation. I'm not actually too sure of if it's direct based on the implementation, but whatever. If you have 3 points, if you have 3 points in the data set, that becomes 9 distance formula checks. If you have something like 30 data points, that quickly becomes 900 distance checks. Yep. And if you have something like 1,000, that becomes 1,000,000 distance checks. So it becomes very expensive very fast is what we were trying to say. All right,
Yep.
that should be it.
Yep. All right, so that was a lot of information, definitely a leg up from our linear regression, which was a bit more simpler, not that much content, a lot more to see. But this K nearest neighbor, KNN algorithm for short, it was a lot to take in. If you guys have any questions, feel free to drop them in the chat. Or if you're ever wondering, you have us on our Google Classroom, you can contact me or Andrew. But other than that, we hope that you guys had a good time. Hopefully, even if you did not take away every little nitty-gritty details, you learned something, learn about the difference potentially between regression and classification, or it just maybe sparked an interest in whole computer science and machine learning. And as always, we hope that you guys will join us back next month in September for our third rendering of Hack Central. And in the meantime, check us out on our Tech Bytes and Teen Trivia programs where you guys can catch us weekly. And yeah, we hope that you guys had a good time. Take care and see you next time. Bye.
Thanks, guys. We'll update the video on the YouTube channel today.